So we're going to start with point slope form. That's the first form. It is the one that we will kind of base all the other three forms on. We already know slope-intercept form, but we're going to base everything off of point slope form. Point slope form uses those two things, a point and a slope. You got to have those two things to write the equation of a line. Point slope form looks like this: y minus y1 equals m parentheses x minus x1. These two things are an ordered pair. X1 comma y1. You've got an ordered pair. This x is the variable x. This y is the variable y. Okay. The m is still what? Slope. It's not changed. That's the same slope we dealt with last week. So that's still the slope. Okay. Those things are the things we got to know. So a point slope form is going to look like that. Y is not going to be by itself to be in point slope form. Okay. So that's how we're going to write our first equations. Okay. Example A. Through -4, +1 with slope of -3 in point slope form. Okay, so one of the things you'll have to be careful of on the quiz and the test is make sure you read what form they want the equation in, because they may have a correct equation, but it's in the wrong form as an extra choice. So here we're going to write this in point slope form, given the point and the slope. So that's super easy. You just plug in the stuff you know. Y1 is +1, x1 is -4. So we got y minus 1. We know the slope is -3, so that goes on the outside of the parentheses. And then x minus -4. The only thing you got to clean up is double negatives. You got a double negative there with the minus -4. So we want to clean that up and write it as y minus 1 equals -3, excuse me, x plus 4. That, and you're done. It really is that easy on the point slope form. You get a point, you get a slope, write the equation in the line in point slope form. You don't have to get y by itself. You don't have to do anything. That's point slope form. Okay. Now, where they make it a little more difficult is when they take and say it goes through -3, +2, and 2, -4, and I'm going to abbreviate point slope form. Okay, point slope form. Okay, what do we have to do first? To write the equation of a line in point slope form, what two things do we need? An x and y coordinate and a slope. Point slope form. Point and a slope. Okay? I've got points, but I don't have a slope. How do I find the slope? Yeah, that -4 minus 2 over 2 minus -3. So that'd be -6 over +5. So my slope is -6 over 5. Now here's where you got to make a choice. Which ordered pair are you going to use? Are you going to use -3, 2 or 2, -4? If you use -3, 2, your answer looks like this. Y minus 2 equals -6 over 5, x minus -3. And you got to simplify that a little bit. Y minus 2, -6 over 5, x plus 3. That is absolutely correct. But that's not the only answer for point slope form. For point slope form, you could also have y minus -4 equals -6 over 5, x minus 2. And when you clean that up a little bit, That's also perfectly correct. It just uses the other point. Okay, so point slope form, you could use either point and it'd be correct. You get two different equations, but that's the same line. If you were to graph those, they are exactly the same line. Okay? So point slope form, depending on which ordered pair you pick to use, what your final answer will look like. So it doesn't always end up being the same. Okay. Which leads us to slope-intercept form, which is the form we're most familiar with. It's the one you've worked with the most over the course of your mathematical careers. Y equals mx plus b, where m is the slope, the same as we've been dealing with forever, and b is the y-intercept, stuff we've already talked about this evening. So this is nothing new. The difference is that we're going to, instead of graphing a line that's given to us, we're going to be given some information and asked to create the equation that goes with it. Okay, so example C, through 0, 6, well, let's do 0, 7 instead of 6. 6 looks too much like a B. With slope of -2. So we got a slope of -2 and it goes to the point 0, 7. What do we know about the point 0, 7? Where's it at? Well, it's not a line. The point 0, 7 is not a line. It's a point, right? On what? On the y-axis. So it is the what to this equation? The y-intercept, right? So B for our equation for this problem would be 7, okay? So because this ordered pair is 0 something, that tells us that this is B. And that's a shortcut that helps us write the equation in slope-intercept form. Because all I really need is a slope and a y-intercept. If they give me the y-intercept as an ordered pair, I can go straight to that and say y is equal to -2x plus 7. And I've written it in slope-intercept form. Okay? So if the ordered pair is a y-intercept, you can go straight there. That's wonderful. That's nice. That's a shortcut. Anything we can do faster is usually better. It comes to math anyway. But what if they told us that it goes through the point -4, +1 with a slope of -3? Is -4, +1, is that on the y-axis? No, definitely not. So I can't use that shortcut here. B is not going to be the 1 because that's not on the y-axis. So I've got to do some more work to get my slope-intercept form of this equation. So the work I'm going to do is I'm going to start with point slope form. Okay? So point slope form says it's y minus 1 is equal to -3 parentheses x minus -4. This problem looks familiar. It should. It was example A. Same problem. Okay? And then what did we do to clean up that point slope form? Yeah, made it plus instead of double negative. And if you want to do that at the first step and just skip writing it, that's I hope you do. Okay. I'm just writing every single step here for my notes. Now, if I want this in slope-intercept form, what do I need to get by itself? Y. I've got to get y by itself. So what's the steps to get y by itself from a point slope form equation? What's the first thing that I should do? Distribute the -3. I got to multiply this -3 to everybody over there. If I do that, I get y minus 1 is equal to -3x minus 12. One more step gets y by itself. Plus 1 to the 12. And there we have -3x minus 11. So now we have an equation that was in point slope form right here, we've written it in slope intercept form. Okay? So point slope form, remember I said it was going to be where we're going to start with everything. When you start with point slope form, we can get into slope intercept form. It took us 2 steps. You may have been taught in the past to do it a different way. You may have been taught to do it this way, which I'm fine with, to plug in -3x plus b and plug in the ordered pair. That's a -4. And that's going to give you 12 plus b is equal to 1. And then you subtract 12. And that's going to be -11 is equal to b. Is b -11 when I did it this way? How many steps did it take me to do that? 1, 2. How many steps did it take me to do this? 1, 2. No way's better than the other. They're both the same. The difference is, if I do it this way, I got to go back and rewrite my equation. If I do it this way, my equation's already done. But it's the same amount of work. So I don't care which way you do it. It doesn't matter to me. A lot of people teach this way, and I'm actually fine with that. I teach that way sometimes too. But since we're doing all 3 forms, I like to use that point slope form as much as I can, just so because you've had probably the least amount of experience with it. So I try to use it more so that you get more experience with it. So the final answer is the same. Y equals -3x minus 11. No matter which way you do that. I don't care. Pick a way. Pick the one you think you're best at and go with it. Okay? Let's do another one. Let's say they said it goes through -3, 2, and 2, -4. Okay, I'm going to write the equation in slope-intercept form that does this. Are either of those points on the y-axis? No. If they were, the x value would be a 0, and neither of those are. So I don't get a shortcut on this one. I just got to go straight through the whole way. Now, what's the first thing that I need to be able to write the equation in either slope-intercept form or point slope form? Say it again. No. I got to do the slope formula. I got to get the slope so that I can start building that equation to get y by itself. So I'm going to do the slope part first. y2 minus y1 over x2 minus x1. So -4 minus 2 over 2 minus -3. That's -6 over 5. That doesn't reduce. I'm going to leave it as a fraction. Now, here's where I've got to make that choice about how I'm going to do the problem. I've also got to make a choice about which ordered pair I want to use. It doesn't matter. They're both equally junky. It doesn't really matter which one you pick. Okay? So I'm going to pick the -3, 2, just the first one. Okay? So if I go to my point slope form, y minus 2 equals -6 over 5. X minus -3 turns into x plus 3. So I went ahead and did that double negative thing. Now I want to get it in slope-intercept form. What do? Distribute. If I distribute -6 over 5x, there's my slope. -6 times -3 is -18 over 5. And I still got y minus 2 over here. That ain't slope-intercept form. It's close, but it ain't quite there yet. What do I need to do now? Add the 2. There's y by itself. That's what I'm looking for. -6 over 5x. And then I just need to do -18 over 5 plus 2. And then how do I turn that decimal back into a fraction? Math, enter. Thank you. -8 over 5. If I use the other ordered pair, would I get the same answer? Yes. Point slope form, no matter which ordered pair you start with, When you get the slope-intercept form, they have to be the same. If they're not, you made a miscalculation somewhere. Okay, so if you're not sure, do it with the other ordered pair and see if you get the same answer. If you do, you probably did it right. Okay, if you don't, then one of them is wrong. Okay, so doesn't matter which order pair you pick, just pick the easiest one and go from there. If you wanted to do it the other way where you're solving for B, you can do that just the same. Doesn't matter which order pair you pick, just pick one of them. Don't mix them up. Pick one ordered pair and stick with it. Okay? Easy stuff there. Not bad. All right, so we've gone to point slope form. We've got slope intercept form. We went from point slope form into slope intercept form. So we got one more form to talk about, and that's standard form. Standard form is the weird one. It's got X and Y on the same side. Slope intercept and point slope had Y on one side and X on the other. Standard form has X and Y on the same side. It looks like this. AX plus BY is equal to C. And I'm just using capital letters there to represent the regular numbers. A, B, and C. There are some rules to standard form. A, B, and C cannot, I'm going to write not, be fractions. They cannot be fractions. No fractions in A, B, and C. Okay, so when you get the standard form, there can't be a decimal, there can't be a fraction. The end. Okay, standard form does not have those in it. Okay, they're integer only. Okay. Now, when we look at standard form, we can take an equation. Let's do, for example, this. Put y equals negative 3x minus 11 into standard form. What form is y equals negative 3x minus 11 in? What form is that original equation there in? It's in slope-intercept form. Okay? Slope-intercept form is really close to standard form. It only needs to move one thing. What one thing needs to move? We need the x and the y on the same side, right? So if I add 3x to both sides, that'll give me 3x plus y is equal to negative 11. Are there any fractions in front of these guys? No. That's standard form. So if you can get it to slope-intercept form, you're one, maybe two steps away from standard form. Okay? So what we're going to work toward is getting it into slope-intercept form and then getting rid of any fractions that show up. So let's look at one that's got a fraction in it so we can see how we can get rid of that. Let's say we had y equals negative 6 over 5x minus 10 over 3. And we want to put that in standard form. So this one's similar to one of the ones we worked with before. Now, what did we do on example F to get it close to standard form, or get it to standard form? We moved the x. Same first step. That step hadn't changed. It's the same right first step. So I'm adding 6 over 5x. That cancels that out on that side, and I get 6 over 5x plus y is equal to negative 10 over 3. That is almost standard form. You got x and y on the same side. That's the first hurdle for standard form. Then the rule is A, B, and C cannot be fractions, but they are. So I've got to figure out a way to get rid of the fractions. Okay, and back when we were last week or the week before, when we were talking about solving equations, and I told you how you could clear out the fractions by multiplying by what?
Common denominator.
A common denominator. That's exactly right. So we look at our fractions. The denominator's bottom part, 5 and 3. What is the common denominator between 5 and 3? 15. Both of those go into 15. And we're going to multiply the entire problem by 15. Each individual piece is multiplied by 15. That will get rid of the fractions. Okay? So I'm going to do that. This times 15, this times 15, this times 15. 6 over 5 times 15. Boom. 18. So I got 18x. 15 times y, I think I don't need a calculator for that. I got that. And then I need 15 times negative 10 over 3. So 15 times negative 10 divided by 3. Negative 50. Are there any fractions in that problem now? No. Okay. The only thing I've got to watch out for is make sure you use the least common denominator. 15 was the least common denominator for this one. But make sure it's the least. If you, for whatever reason, didn't find the least common denominator, and maybe you multiply this by 30, because 5 and 3 both go into 30, that would get rid of the fractions, but it wouldn't be in standard form. Because what you've got to look for is make sure that everybody isn't divisible by the same number. 18 and 15 and 50 don't have anything other than 1 that goes into all of them. Okay, so that's the other rule for standard form, is you can't have a common factor that you can divide by. Okay, so that one is in standard form. So if you will just be careful and use the least common denominator, you're going to be safe on that. Just be careful of that and check there at the end to make sure you're not using a just a common denominator, but using the least common denominator. All right, so standard form cannot have fractions in it. It's got to have x and y on the same side. Okay, so we've seen some that were already in slope-intercept form, and we moved them into standard form. Now let's start from just from scratch and say, okay, here's the information. Let's write it in all three forms. Okay. All right. Through the point 1, 1 and 2, 4 in all three forms. If I'm going to write this in all three forms, which form do I start with? Point slope form. That's right, because I don't have a y-intercept. The ordered pairs aren't y-intercepts, so I can't go straight to that. So what's the first thing I got to find, though? Slope. Okay. 4 minus 1, 2 minus 1, 3 over 1, that's 3. So the slope is 3 for that. Okay, I've got the slope. Now I need to do point slope form. So I'm going to do the first, number 1, I'm going to do point slope form. Which ordered pair would you pick to use? 1, 1. I like 1, 1 because I can't screw it up, right? I can't put the wrong thing in the wrong spot because there's the same number. So that's a safe one to use. That helps me out. So I'm going to do y minus 1 equals 3 parentheses x minus 1. What's the other equation for point slope form? Because remember, you could use either one. What would the other equation be? Y minus what? If I use this other order. Y minus 4, 3 parentheses x minus 2. That would be just as correct as this. Okay, so point slope form is either this or y minus 4, 3 parentheses x minus 2. It's one of those. You don't have to do both. It's one of those. Okay? Next, let's go into slope-intercept form. Slope-intercept form, since we've already done the work to get it in point-slope form, I'm just going to start from there and go into and get y by itself, and I'll be done with slope-intercept form. Whichever ordered pair you used, y'all pick the 1, 1. That's the one I'm going to work from. Okay, so I'm going to work from the y minus 1 equals 3 parentheses x minus 1. And I'm just going to get y by itself, and I'll be in slope-intercept form, and I'm almost done. So distribute 3x minus 3. What's the next step? Move the 1 by addition. 3x minus 2. There's my slope-intercept form. If I had worked out the second point-slope form, would I get the same slope-intercept form? Yes. No matter which ordered pair you picked in point-slope form, you better get the same slope-intercept form. They're always the same. Okay? So everybody's slope-intercept forms should always be the same. Okay? Last thing is the standard form. Standard form just means get x and y on the same side and make sure there are no fractions. Okay? So I've got y equals 3x minus 2. I'm one step away. How do I move? Move the 3x by subtraction. Negative 3x plus y is equal to negative 2. I'm going to throw a kink in things here. Why are those both answers? Because they're both correct. Why? What changed about the second one compared to the first one? All of the, well, not, was it just the negative signs that changed? Everybody changed signs, right? So it was like I multiplied this whole problem by -1, and I got this. That's legal to do. These are equivalent equations. They're the same. The signs are different on every single piece, but if you worked both of these back out into slope-intercept form, they would be exactly the same. That's why they're both legitimate answers for that. So be careful of that. That is pretty common when there's a negative in front of the x for them to do that. Just change the sign to everybody and make the x positive. It's not that long. This book doesn't always do that. It just, I think it's just whenever the author decided, hey, I'm going to do that for this problem. That's the only reason I can find so far with this particular author in the textbook. But both of those are correct. On a quiz, it's multiple choice, or a test, it's multiple choice. You got to understand, hey, I may have got this, but this may be the only answer choice that it's the same thing. It's just all the signs have changed. So be careful of that. That does come up some out of this. But it's not too bad. All right, so we did every form there. We did point-slope form, we did slope-intercept form, and we did standard form, and we found the slope on our own. So we did everything we could to write the equation of a line there. Now, that leads us into the next type of lines, which are parallel lines. What do you know about parallel lines? You know,
two lines, they never touch.
Never cross, never touch. Okay, so this wall and that wall back there, parallel. They never touch each other, right? Never cross. What do we know about the equations of parallel lines? Particularly the slope-intercept form of the equations for parallel lines. So y'all said they never touch / intersect. Yes, ma'am. Same. Yeah. What's the same? The whole equation or just part of it? Exactly right. So it could be the whole equation because then they'd be the same exact line, so that's not parallel. Parallel means they go in the same direction, but they're just slightly different. What's the same about them if they go the same direction? slope's the same. Okay, parallel lines never touch, never intersect, and they have the same slope. That's the part that helps us out, because we're going to write the equation of a line that's parallel to another, and we got to have the slope to be able to do it. Okay, same slope. Okay, so let's get an example here. Let's say that it goes through 3, 5, and it's parallel to 2x plus 5y is equal to 4. What the what? That's not the slope. That's a standard form. How do I get slope from a standard form? Slope-intercept form. Yeah, that's right. If we take this standard form problem and get it y by itself, we can pick the slope off and use it. That's what we got to do. So how do we get there? Move the 2x by subtraction. Good job. So that's 5y is equal to negative 2x plus 4. Now what? Divide by 5. So y is equal to negative 2/5 x plus 4/5. What part of that is the part I need? The 2/5. That number in front of x is the only part I need. That's my slope. The slope of my new line that goes through the point 3, 5 has that same slope. Okay? So if I'm going to write the equation of a line that goes through a certain point and has this slope, what form do I start with? Point slope. That's the easiest form to start with because it's got the stuff you need. So I'm going to do y minus 5 equals negative 2/5 x minus 3. The slopes are the same. Let's write that in slope-intercept form. So what do I do to get that into slope-intercept form? Distribute. So y minus 5 is equal to negative 2/5 x plus 6/5. One more step to get it into slope-intercept form. Move the 5. Y is equal to negative 2/5 x plus something. So 6/5 plus 5. Math, enter 31/5. So there's slope-intercept form. So that's slope int. This is point slope form. While we're at it, let's go ahead and write that in standard form. So we get the practice of doing that as well. So how do we write that equation into standard form? Move the x over there with the y by addition. So that's 2/5 x 2/5x plus y is equal to 31/5. Oh, what's the problem? Got fractions. So what's the least common denominator between 2/5 and 31/5? Yeah, just plain old fun. Since the denominators are the same, 5 is the one we want to multiply by. That makes this pretty easy because when I multiply everybody by 5, the 5s on the bottom just cancel each other out. So that's going to be 2x plus 5y is equal to 31. And there is standard form. Now, on quiz or test, I'm not going to ask you for all 3 forms, but be able to go to any of the 3 forms that are there. Okay? So we're in notes here, we're just practicing all of them, but be able to move to any of the forms there. Point slope forms where you're always going to start, though. And then go get y by itself to get slope-intercept form, and then standard form, you're either 1 or 2 steps away from it. Okay, so parallel lines have what? Same slope. Parallel lines have the same slope. You got to remember that, got to know that. Same slope for parallel lines. The work is all the same. Is what we're doing. Doing the same thing in this whole section. Okay. Last type of line is perpendicular lines. My handwriting is getting worse as the days go on. What do you guys know about perpendicular lines? Just general knowledge. From past math classes, life, anything that we reject perpendicular lines. Are they parallel?
No.
Definitely not. So that means they do what? They cross, they touch, they intersect. Okay? So perpendicular lines are pretty special in that they intersect at what angle? Example of perpendicular would be that wall and the ceiling, or that wall and the floor. 90-degree angles. Perpendicular lines intersect at 90-degree angles. Okay. The slopes are opposite reciprocals. Opposite reciprocals. That means flip and change. Flip and change. Slopes are the opposite reciprocals. Okay? Perpendicular lines meet at 90-degree angles. The way to make that happen on a coordinate plane is to flip and change the sign of the slope. Flip it over, change it from either positive to negative or negative to positive. Whichever one it was originally, it's the other one on the perpendicular. Okay? I use a little notation here. Notation for perpendicular is an upside down capital T. That's what that looks like. That's the notation for perpendicular. So you don't have to write out the word perpendicular 45 times. So if you just use that symbol, I'm fine with that. Okay. Now, so if we've got an equation or to write for a line that goes through 3, 5 perpendicular to 2x plus 5y equals 8. We want to write the equation of a line that does that. We're going to do it in all three forms again just to get the practice for it. So perpendicular to that. So just like parallel, what do we need from this equation? We need the slope. We're not going to use the same slope, but we got to find out what this one was to begin with. Okay? So what do we need to do that equation? Get y by itself. That's all we got to do. 5y is equal to negative 2x plus 8. Next step. Divide by 5. Everybody gets divided by 5. The only part that I care anything about for this problem is the slope, which is what? Negative 2/5. So the perpendicular slope, and this is where I use that symbol. Perpendicular slope. I always usually write that there so I make sure that I use the right one. What would if the original slope is negative 2/5, perpendicular means flip and change. So we flip it over and then change the sign. So our new slope will be positive 5/2. Flip this slope and change the sign. Most common mistake is folks will flip it over and forget to change the sign. That's what happens most of the time in this section. Folks forget to change the sign. I don't know why that happens more than folks forgetting to flip it, but folks forget to change the sign more than they forget to flip it. So change that to 5/2, and then I rewrite my equation with that point and that new slope. So point slope is where I'm starting. That's the easiest one to start with because I have a slope and a point that it goes through. So y minus 5, 5 over 2, x minus 3. And I've got point slope form. That's the easiest one. That's why I like it. So not a whole lot of work at all. Now, let's get that into slope-intercept form. Distribute the 5 over 2. Be 15 over 2. You distribute 5 over 2 to the 3. And then next step. One more step, we're in slope-intercept form. Add the 5. So I'm adding 5 to 15 over negative 15 over 2. I don't know what that is, so I'm just going to type it in. Negative 15 over 2 plus 5. Math, enter. Negative 5 over 2. Y is equal to 5 over 2 x minus 5 over 2. Boom. Slope-intercept. Okay. Last form is standard. 1 or 2 steps away from that. So let's go to standard form. What do I do to get there? Move the x over. So I'm going to move that x over by subtracting 5 over 2x from both sides. All right, so that's going to be negative 5 over 2x plus y is equal to negative 5 over 2. No, that is almost standard form. One more thing I got to do. Why am I using 2? It's the least common denominator, lowest number that all of them have in common. It's the same denominator on all of them, so I'm multiplying everybody by 2. That's negative 5x plus 2y is equal to negative 5. What would be an equivalent answer for that? Equals how much? Positive 5 there. Change the sign of everybody. Either of those. Both are the same. On labs and stuff, I take either one. Make sure on multiple choice Canvas quizzes, it's going to be one of those that are there. It may not be that one. It probably won't be that one. If this one's not there, look for that. Easy stuff there. All right. Questions about equations of lines. Going once, twice. So, all right, let's go to the last section. New section. We're going to do some inequalities and be out of here. So this one goes back to chapter 1, which is usually a good sign, because that means it's getting easier. Solving inequalities. Inequalities are a lot like equations. There's only just a slight difference in 1 or 2 types of inequalities that we solve. That things can change a little bit, but the way the answers are written, excuse me, is much different. So we're going to write the answers in 3 different ways. We're going to write it in set notation, interval notation, and then we're going to draw it on a number line. So it's 3 different ways that we're going to express our answers with inequalities. So we got 1, 2, 3, 4, 5 examples. Can y'all hang for 5 examples? I'll get you out of here by 8 o'clock. At least. All right. 3x plus 7 is greater than 13. Simple solving. What do we do first? Subtract 7. This part you guys have no problem with. Next step. Divide by 3. X is greater than 2. All right, now here's where we got to write our answers in the 3 different ways. This is the part that folks tend to have a little bit of trouble with. The first method is called set notation. Curly brace, whatever variable you got, ours has x in it, so I'm going to put x, and then you put this straight up and down bar, like that. X, and the way it reads is x such that, and then we're going to put this inequality. X is greater than 2. If your variable's an n, you're going to use the letter n. X is greater than 2. Well, that's not very hard. Set notation is really easy. Okay? Interval notation and the number line go hand in hand. So we're going to do those together. So we're going to do interval notation and then the graph. I think interval notation is really easy to understand if you've got the graph there. So I'm going to draw a number line. Doesn't have to be very long. And I'm going to put the number that my answer is, I'm going to put in the middle. 2 is my answer. So what numbers are to the left of 2? 1, 0, and if you got room, go -1. What numbers are to the right of 2? Yeah, 3, 4, 5. You keep going if you got room. Okay. Now, here's where the interval notation and the graph go together. Our inequality says all the x's are greater than 2. So where are the numbers that are greater than 2? They're on this side, right? So is 2 an answer? No, 2 is not greater than itself, right? So we don't include the 2. In the past, in your high school math classes, you may have put open circles. Y'all remember doing that? Okay, so that's kind of high school notation. We're going to graduate to the interval notation for this. The equivalent to an open circle is a parenthesis in interval notation. So we're going to put a parenthesis right there on the 2, like that. And notice how it's opening, and the answers are to this side, and we're going to go to the right with our arrow like that. What that does is that says all the answers start just after 2 and go to infinity. Go forward, because positive infinity would be this way, right? So the interval notation for that is parenthesis 2, comma, infinity. Number line, interval notation, hand in hand. They go together. To me, it makes the interval notation make sense. Okay? Open circle, parenthesis. Closed circle is going to be a square bracket. We'll get one of those in a second. Okay? All right, so got to be able to write it in all 3 forms. Let's look at example B. This is the second one. 4 more. Let's say we had -3x plus 5 is greater than or equal to -7. Let's solve that inequality. First step. Subtract 5 from both sides. Because they're adding 5, so we want to subtract it. So there's -3x greater than or equal to -12. Next step, divide by -3. Here's the step that most people forget, or some people don't. And it's just, you don't do this on equations, only on inequalities. Anytime we multiply or divide by a negative to solve the problem, you got to flip your symbol. Okay? So we flip the symbol to be a less than symbol, less than or equal to. And then -12 divided by -3 is 4. It has nothing to do with the negative on the 12. Everything to do with the negative on the number that was with the variable. Okay? Only the number with the variable can make that happen. Okay? Now, let's write the answers in set, interval, and graph for this. The set's the super easy part. How does it work? curly bracket, bar, and then write your inequality. That's if you ended up with your x on the other side, it's not completely wrong to just write it with like 4 is greater than x, something like that. But in most cases, you want to flip it around where your x is on the left side. It's not wrong mathematically, but the way you normally see answers, you're going to have the variable on the left. That's just how you're going to see it most of the time, and that'll help you when it comes to picking a multiple choice answer on a quiz or something. All right, let's go interval and graph. All right, so the graph, again, it doesn't have to be real long, and you don't have to have a lot of numbers on here. We just got to have the 4 in the middle, 3, 2, 5, 6. Just a couple numbers on each side is fine with me. Now, is 4 an answer to our problem? Yes, because it has the equal to mark on it. So that means in high school, you would have put a closed circle, or colored in circle right there. Okay? What we're going to do is a square bracket. And which direction are all the other answers? So the x's that are less than or equal to 4, where's less than 4? 3 and 2 are. So I'm going to go that way. Okay? So when I draw my bracket, I'm going to open it going to the left, like that. So square bracket. So when I write my interval notation, if I keep going here, what number is way out here? Negative what? Infinity. And it goes all the way up to 4 and stops. So I'm going to start with negative infinity and go to 4. On the infinities, it's always a parenthesis because you can never get there. All right. So always a parenthesis on the infinities. Bracket on the 4 there for this one. Okay? Super easy, right? Not hard at all. Boom, boom, boom. Let's do one that's got variables on both sides. Step C, 4 minus 3x less than or equal to 7 plus 2x. All right. What do we do for this? Subtracting 4 would be a good move. Get the like terms together. I like that. So that's going to get us negative 3x is less than or equal to 3 plus 2x. So a good start. Now, all right, so what's the other like term? All right, so do I need to move the negative 3x or the positive 2x? Why not move the 3x? Because there wouldn't be anything left over there. It'd be an unbalanced thing. So we want to get x's on one side, regular numbers on the other. It doesn't really matter which way you do that, just as long as you end up with x's on one side and numbers on the other. So if I move this 2x, I'm going to subtract it. So that's negative 5x less than or equal to 3. And now one more step gets x by itself. Divide by the negative 5. Uh-oh. What does that do? Flips the symbol and changes, and that makes that a fraction, negative 3/5. Which for set notation doesn't really affect anything. Curly brace. There we go. X bar, x is greater than or equal to negative 3/5. All right, so we're going to get the graph and the interval. Negative 3/5 is where my answer's at, so I'm going to put that in the middle. I'll show you how I do fractions on a number line. I think it's the easiest way to get there. If you just have one answer, then having fractions on your number line makes a little bit more sense. When we get to a compound one in just a second, you may have fractions and regular ones, and then that's going to be estimate. So if we just have a fraction, then I can take this fraction and move it left and right. So if I go to the left of -3/5, if it were just the regular number -3, I'd have -4, -5, right? So I'm going to do the same thing, but I'm just going to do the numerator of my fraction. So I would have -4/5, and technically this is -5/5, but what do we know what -5/5 is? -1. So I'm just going to change that to a -1. And then I'm going to go the other direction on the numerator. So that'd be -2/5, and then -1/5. And then the next number, if I had room, I put 0 over 5. Okay. Now, what goes on the 3/5? Bracket or parenthesis? Bracket, and which way are our answers going, left or right? Going to the right, because its x's are greater than that. So I'm going to have a bracket, square bracket, going to the right, and then my answer be bracket, -3/5 to what? Positive infinity. Might take you a minute to get used to writing infinities. I made them start doing this. They didn't whine about the math. They whined about writing infinity because theirs didn't look right. Mine never looked right either way. It's a sideways 8, but that's the only way I know how to draw them. So don't ever get me to put an infinity tattoo on you. That's all right. Let's get one of those. I said something about a compound one. Let's get one of those. -2 less than 5 plus 3x less than 20. Compound is it's got more than one side. The x is in the middle. We want to get x by itself in the middle. It's like this. We want to get x by itself in the middle. Okay? So what that means is I've got to take this and I've got to get rid of the 5 in the middle. But if I move it from the middle, it's got to go to this end and to that end. Okay? So it goes everywhere. So that's a positive 5. So how do I get rid of it? Subtracting. So I'm subtracting 5 from the middle, but I'm also subtracting it from the left side and from the right side. It's got to do all of those. So that's going to give me -7 less than 3x less than 15. And now, what do I do to get x by itself? Divide by 3. If I divide everybody by 3, got 5 on that end. I got a fraction on this end. Well, that's wonderful. Why did I not put my symbols? I didn't divide by negative, right? I divided into a negative, but that's okay. It's all about the number that's with x. So it's a +3, so when I divide by +3, I don't flip symbols. Okay? Be careful of that. That's an easy thing to mess up. Now, get our answers in set and interval notation and graph. So set, again, that's the super easy one. Curly brace, x bar, -7/3, less than x, less than 5. Okay? Interval. And graph. All right, so here's one where we've got a fraction and an integer mixed together. So when I have that on my number lines, I usually will just do regular numbers on the number line and then estimate where the fraction's at. Okay, so I know I've got to have 5 on there. So I'm going to go 5, 6, 7. And then what do I know that -7/3 is close to? It's between what? -2 and it's -2 and 1/3, right? You think about it as a mixed number. No, we're not supposed to do that in college. So we're not supposed to do that. But we got to estimate where it's at, so that's what we got to do. So it's -2.3 repeating. We go decimal with it. So we know it's between -2 and -3. So I need to go out all the way to -3 at least. 4, 3, 2, 1, 0, 1. Give myself a little more space here. -2, -3. All right, there I have my number line. And now, each of these numbers are going to have what on them, on the number line? Parentheses, because neither of them have an equal to mark. Okay? Where are the answers in between them? Okay? So I'm going to go to 5 and put a parenthesis opening this direction. I'm going to go to where, estimating about where -7/3 would be, which is about right there, about a third of the way to -3. Put your parenthesis right there. And go. Boom. Answers are in the middle. So the interval notation, super easy, -7/3, comma 5. Looks like an ordered pair, but it's an interval. That's where the folks get confused sometimes, because it starts blurring lines when you interval notation, ordered pair. We're solving inequalities, so you know it's an interval. Pretty easy thing. Let's do one more, and we're out of here, guys. This is the last one. Guys and gals, sorry. Don't want to offend anybody. 16 less than or equal to 2x minus 4 is less than 18. So a mix and match on the inequality symbols here. We got one that's got an equal to mark, one that doesn't, and that's legal. That's okay to have. That happens. What do we do with that one? Add 4 everywhere. Good job. 20 less than or equal to 2x less than 22. Divide by 2. That works. 10 less than or equal to x less than 11. Oh, that's not very much room, is it? Set notation. That's one alike. It's easy. Curly brace. Curly brace. Let's see if we can write the interval without the graph, and then we'll graph it. All right, so what's our lowest answer? 10. Our highest answer, 11. Now on the 10, what do we put? A bracket, because it has an equal to symbol. And on the 11, parentheses, because it doesn't have an equal to mark. So we can get the interval from the set notation, not just the graph. But I think the graph makes it easier. It honestly does to me. Graph, we don't have to have much here. 9, 10. Bracket, parenthesis, answers in between. That's pretty boring and easy, right? All right. 1.7, that section in your book, 1 through 37 is a good spot to look. And on section 2.5, which is the first section we talk about tonight, 1 through 51, it's a good set of numbers out of the textbook if you want to practice a little bit before you do your Canvas quizzes and things. So I will try to get your Canvas quizzes posted a little sooner this week than I did last week. Apologize about that. And then next week we'll come in. We got 3 labs and our exam. So be looking for a review for the exam and your Canvas quizzes for this week. And then we'll come in and do labs and then take the test. And then you're on fall break from math class for a couple of weeks. Okay? Got any questions? Email me. I'll be glad to try to get back to you as soon as possible. Y'all have a great week. Let me know if you need anything.